It's an honor to introduce my distinguished panelists today. I will start from you, Graham. Graham Alabaster is the Chief of Section at the UN Habitat. Next to him is Mourad Beji, is Chief Software Officer at Pascal. Anousheh Ansari, the CEO of the X Prize Foundation. And then we have Anna Fontcuberta, the President-elect, and I think congratulations are in good order, of the École Polytechnique Fédérale de Lausanne. And remotely, we are joined by Lidia Brito, Assistant Director General for Natural Sciences at UNESCO. Welcome to you all. I think during the summit, starting from the opening ceremony, we've heard, and also heard it today, that the Open Quantum Institute is now into its pilot phase that is hosted here at CERN, started in March. And we have a clear commitment to deliver tangible use cases, showing how both quantum technologies and education hold the potentials of help addressing SDG challenges. I think to set the scene for the first part of the panel, I would like to invite you all to watch a short video that of the specific of the work that has been happening in the last year.
Everyone needs water every day, but global water shortages loom with climate change and aging water infrastructure. Day zero, the day a city has zero water available, happened already in Sao Paulo, Brazil, and Cape Town, South Africa. In many cities, half the water is lost to leaks, old infrastructure, or illegal use. If we could improve the placement of water leak detectors, risk of water losses could be prevented. Water system pipes can be modeled computationally, but the more complex the water distribution systems, the harder it becomes for classical computers. Quantum computing could tackle such complex problems and improve the prediction of leaks. This is one of the many examples of why the Open Quantum Institute was created. OQI anticipates the global impact of quantum computing. It brings together quantum scientists, domain and sustainability experts from industry and academia, and diplomatic stakeholders to rigorously explore how quantum computing could help achieve the UN Sustainable Development Goals, a blueprint for all humanity and the planet. OQI's teams are pioneers, preparing today for when technology matures to maximize its impact on humanity, as for instance, optimizing the production of nutritious food locally, accelerating novel antibacterial discovery, removing forever chemicals in water, predicting flood in regions at risk, or maximizing power generated by renewable energy. The water leak use case is currently being explored by a team of experts from UN Habitat, uclavis.io, Reply, and Pascal. Such could be applied to other global challenges, which would benefit billions in cities, especially the most vulnerable. The OQI works to ensure that everyone benefits from quantum computing. The OQI, hosted by CERN, born at GESDA, supported by UBS.
Thank you. Thanks very much. Now, Graham, UN Habitat. Why are you engaging in this water leak detection use case? What do you think is the impact that you're trying to achieve, and how likely is it?
Erica, thank you very much. Excellencies, ladies and gentlemen. Habitat, as you know, is the organization in the UN which deals with sustainable urbanization. And of course, the global priorities for us at the moment are the provision of housing, which in all areas of the world is lacking, and access to basic services. And of all of the basic services, water and sanitation are the most important. But of course, there's still a large number of people in the world who have not got access to adequate drinking water. Some of the times that's due to a scarcity crisis, due to lack of water in the area, but it's often also the result of a management crisis, because in many cities, the aging infrastructure, leaks, there's illegal connections, particularly to the informal settlements. And of course, what that means is the price of water becomes more expensive. If you go into the slums and the poor amongst the vulnerable people, they can pay often as much as 10% of their income just to get enough water to drink. So this particular use case is of critical importance for global development. And if in cities we can save these large amounts of water that's lost, that can be anything up to 60 and 70% in some. It can be huge. Even in many developed economies, the unaccounted for water is very, very high. So in principle, if we can save that water and make it go further, we can ensure that the underserved or the unserved get access to water. We can also delay investments in critical infrastructure. I had a project many years ago in the city of Dakar in Senegal, where they bring water from 250 kilometers to the city. By doing a saving of water in the city of Dakar, we managed to delay the investment in the long pipeline for 5 years. So there's a whole range of good opportunities that we can get if we can improve water distribution. Another quick linkage which I'll share with you, in times of crisis in cities, because water is intermittent, people will store water in their households. The storage of water is a good breeding ground for mosquitoes, and the issues of diseases like dengue and the urbanization of malaria are also affected by water storage at households. So by saving water, by supplying those who are underserved, we can have a very wide impact, not only on the immediate needs, but also on many related issues. Water is not just, of course, about technical solutions to fix leaks. There's also many governance issues around water at local level. I remember some years ago, I was working in a particular small town where the Minister of Water had persuaded the utility to send 70% of the water from the treatment works to his farm 5 kilometers away. And I was the one who had to go in front of the minister and say to him politely that the people in his city were not getting water because he was taking far too much for his farm. So, even at the local level, there's some diplomacy aspects to deal with. So the idea is that with this technical solution to saving water in cities, we can make a whole load of changes. And the reason we need quantum computers to do this is because the networks are very, very complex. You might think a pipe network in a city is a simple system, but it's not. Because in many cases, in many cities, the infrastructure is so old, there were no assets of exactly where the facilities are. In many cities in the developing world, the proportion of vulnerable people can be as high as 50%. Sub-Saharan Africa, it's normal for 50% of the people to live in slums. They rely on illegal connections to the city networks. So this is a very, very complex problem that needs solving. If you want to do that, you have to put bulk meters into the system, but where you put those meters within the network is, of course, also a very difficult solution because it's also expensive to monitor a system. So that, in essence, is what this particular use case is about. It's optimizing, making the most of what we've got for water in cities.
Excellent. This gives a great segue to Mourad. We're not going to solve the governance issues, but definitely we hear your message loud and clear. Technology can address a certain set of the problems, but it has to be more holistic. And this is why I think the OQI being a multi-stakeholder platform adds a lot of value to and a lot of hope to addressing these issues. But Mourad, let me turn to you. I mean, you represent Pascal, a relatively young company. What are your insights into this use case? Why is your company working in this area? What do you find the benefits for your company as part of a shared value creation? And what do you see the benefits for providing a technological solution to a use case like the water leak one?
Thank you for the question, and good afternoon, everyone. So at Pascal, we're a full-stack company in quantum computing. That means that we build processors, but we also develop software and applications that run on that. So first, why would anyone be interested in solving problems with quantum in general? In our global world today, many organizations and institutions have to face problems that are hard to solve computationally. Many problems in industry are limited by our capacity to compute lots of things and compute them fast. And networks are a very good example today. In the past decades, we've seen a huge evolution of high-performance computing, from the first clusters in the 80s to the advent of GPUs to our exascale supercomputers today. But we're getting closer to the limits of what classical computing can do. And at Pascal, we believe that quantum-centric supercomputing is the next revolution that will allow high-performance computing to bypass its current bottlenecks. So the goal, and Sabrina mentioned that earlier today, is not to replace HPC with quantum, it's rather to augment it and to come and improve parts of it. Not all applications, of course, are fit for quantum. You don't need a quantum computer to run your internet browser. But there are a few applications that at least have been identified at Pascal where quantum can have a very big impact. The first one is quantum simulation, simulating quantum systems, which can be useful in chemistry, in material science. The second one is optimization, so optimizing networks, optimizing graphs. This can also be used in mission planning, scheduling, and other areas in combinatorial optimization. And the third one is quantum machine learning. And that one has a very vast area of applications ranging, again, from chemistry to fraud detection. So complexity and speed are not the only bottlenecks. They're often mentioned as limits, but they're not the only bottlenecks. Energy consumption is also a big problem for supercomputers today. So a standard supercomputer uses between 1 and 10 megawatts, and this is really a lot. We believe quantum computers can also be a solution to that. So the type of processors we build at Pascal, for example, consume a few kilowatts, which is almost 4 orders of magnitude difference. And it could even be plugged on a regular plug at anybody's house. So yeah, we believe quantum is really going to be a revolution for HPC, and so to solve these complex challenges. But why is a private company like us interested in solving societal problems? So there is more than one reason to that. The first one is that developing applications and use cases of quantum computing today is good for us. This is a new technology. It uses a unique and exotic paradigm. And in the process of tackling these societal challenges, these societal problems, the teams at OQI will explore new lands, open new paths, build new algorithms, new primitives, and especially bridge the gap with domain expertise in specific fields. And this is just great for us. This is a very good driver for development. This will show us new ways of using our technology, and, for example, developing optimization algorithms for solving for optimizing water distribution networks could then be leveraged for network optimization or for electrical grids. So yeah, that's the first reason, but a company is also made of individuals. For a company, it's very important to make business to be successful, but as individuals, it's also very rewarding to be able to work on things that have a positive impact on other people, on society, or on the planet. So this is a very good cause to work with, but it's also a great way to attract talents. So this is also a culture we want to foster, and we believe that serving the interests of society is not necessarily at odds with making profit. So at Pascal today, it's very important for us to put the technology in the hand of people. Building a strong and educated community is part of our strategic objectives, and we're committed to participating in the efforts of capacity building and in training the next generation of quantum developers. So this is also why we're very engaged with the Open Quantum Institute in providing access to quantum computing and supporting teams to tackle challenges to try to solve the SDGs. And we're very proud to see that the highlighted use case today, the water leak detection use case, was initiated during a hackathon launched by Pascal last year and successfully moved to the umbrella of the OQI for further exploration. And yeah, this is really great from our perspective. So yeah, following the success of our hackathon last year, we had 700 participants and I think 75 projects. We're going to launch a new hackathon also on trying to leverage quantum AI to tackle societal challenges. And yeah, we're going to give more information on that by end of the year, hopefully.
Excellent, thank you. Thank you very much. It was interesting to hear how the philosophy of your company of doing well while doing good is embraced so warmly by Pascal, and I hope that other commercial providers are also listening of what are some of the philosophy behind getting engaged into providing both their expertise and their resources to specific use cases to not only support the the solution of SDG challenges, but also motivating their own staff and co-developing and exploring new potentials, solutions that they could be applied elsewhere. So thank you for that insight. But as you said, there are a number of applications of quantum computing and different use cases that can be explored. In fact, the one that we saw today is one of the 12 use cases that are being explored by the OQI community, and are in different phases of development. I think we'll have a slide that, perfect, that kind of summarizes the current status of this exploration from the phase one, where there is really still identifying partners, both from academic institutions, from UN agencies or international agencies that would like to promote the SDG case or validate the SDG case into academic institution, private sector. And then those who are more advanced, as I said, the phase two that have been with us for longer and will be able to actually hopefully bring them to some kind of examples by the next time we get together. We'll be able to show some initial results that will be quite exciting. So it's a good pipeline coming in. It's a good set of resources, and a good ideas and engagement. Thank you for that. But as we talk about ideas and engagement, Anousheh, maybe I can turn to you as a source of inspiration for the OQI team. You actually you are a member of the advisory committee, but you also been one of the main drivers of the formulation of the OQI from the get-go, when it was just as small as an initial idea in the GESDA list. So it's exciting. It's very glad to have you here. And I think, as Sandro was saying, the X Prize Foundation actually launched a competition earlier this year. What have been your learning so far? Where are you? Why did you launch this? Can you give us a bit more detail?
Of course. So for those who don't know X Prize, we're a nonprofit organization, 30 years old. And our main driver, our main mission is to drive innovation and capital focused on solving humanity's biggest challenges. And I had the privilege of being involved with GESDA in very early days and co-chairing the quantum track, where the OQI idea was born and developed. And I am really excited to see the progress and how it's been now hosted here at CERN, and the potential it has for the future. At the X Prize, we deal with a lot of technologies that are advancing and will impact the world. And our lens to look at these technologies is to how we can harness this powerful, innovative energy toward good. And also, we put a lens of equity and impact on society on it as well. And that's why quantum was an area of great interest to us. We understood that this is going to have a big impact on society, and it will be something that requires more awareness. So as far as we could see, that a lot of initial activities driven by businesses were focused on commercial applications, such as encryption, sensing, and in the financial sector. So we wanted to make sure this powerful technology also develops talent focused on solving some of the societal important problems that we were facing. So the competition was a perfect means of doing that, and really well aligned with OQI's mission. And if you remember the slide that Sandro shared with those 4 areas of focus, 4 pillars, it's probably going to help advance those 3 first pillars. If you could have this next slide. Yes. So the prize was launched in March. It's a 3 years competition, $5 million. And the competition is basically asking the world to develop algorithms, new algorithms, or use existing algorithms towards solving one of the SDGs or problems, SDG-type problems that society is facing, And these are problems that are complex or too resource intensive for classical computing to be able to solve effectively. Part of the prize is to make sure that we ask the entire world to participate. So these capabilities are built globally and equitably, but also we want to make sure that we prove that these algorithms work. So this is to put these algorithms to test through an advanced group of advisors and judges that we have recruited from around the globe. So to date, once we announced, we opened it up to registration. We've had so far 240 teams who've registered from 43 countries, but the registration is open, and we have actually 72 countries that have shown interest. As you can see, we have good diversity. We would love to use this forum, OQI, and other activities to increase participation from the rest of the world. Since we've been around 30 years, mostly in US, homed in US, we're more known in the United States, so we have a lot more participation from US. But as you can see, Europe and Central Asia has also a good chunk of teams registered already. So we're very excited to push this forward and looking forward to how we can advance this. And this was made possible through sponsorship from Google Quantum AI Group and GESDA, and in collaboration with OQI, and hope to bring a lot of these use cases and teams who come through XPRIZE competition to OQI.
Thank you. If I may ask a question, but I'm sure is in the mind of many, when are you going to announce the winners?
Well, this is 3 years, so we're expecting March to announce the final winners, but there are, throughout the competition, we'll be announcing advancements. So there is the first gate, the teams are submitting ideas. Actually, 2 of the ideas are also the ideas that are in the pipeline of OQI. And as they prove that their concepts are valid, they go to the next stage. We will have a milestone in the middle of the competition in about a year or so, and then the finals will be March 2026. So perhaps at this forum in 2026, we will announce the winners.
Excellent. We look forward to that. Thank you. Thanks very much. Now I'd like you to turn to the second part, the second question I announced earlier, because now we've heard about a number of ways in which, just a specific example of how quantum computing has the potential of being leveraged for societal impact. We heard of some of the ways in which we can source use cases and support the wide community of researchers, private sectors, funders, and UN agencies to explore them. Now the question is about capacities, because how we can prepare citizens the world over to benefit from and contribute to the development of quantum technologies. Because in order for the benefits to be shared by citizens around the world, there is a real need both to raise awareness about the potential, the threats, the needs for governance, but also equip the populations with the skill sets to use them and to become active, participants in this new technological ecosystem. So this year, in June, the UN declared 2025 to be the UN Year of Quantum Science and Technology. And OQI is part of the steering committee that is supporting the organization of the events. And there's a very exciting calendar of events ahead of us. But maybe I'll turn to you, Lidia, if I may, to tell us a bit more why the UN already started a couple of years ago to push the international community to put the focus on quantum. Why is quantum front and center in this way? What is the value from your perspective?
Well, thank you very much, and a pleasure to participate, even if remotely, and apologies that I could not be in GESDA summit in presence. But let me start by why does the UN decided to designate next year as the International Year of Quantum Science and Technology. And I think the interventions that we heard before from you, Enrica, and from the other panelists really show that there is a strong recognition, global recognition of the immense potential of quantum science and technology to really to transform and to come up with possible solutions for many of the global challenges that are related to sustainable development. And we heard about water and many other possibilities, but we could also spoke about healthcare, cybersecurity, advancing computing, as was mentioned, and many others. So we know that quantum science and technology are already becoming a game changer in the sustainable development agenda. But I think by declaring the next year International Year of Quantum Science and Technology, what the UN is saying is we should not only celebrate the advancements of science and technology that can bring us a lot of solutions, so the scientific and technological advancements and achievements, but is really, this year is really to ensuring that quantum advancements benefit everyone, regardless of geographic or economic standing. I was looking at the price and the participations, and for example, there is no Sub-Saharan Africa groups or teams working and competing in this very interesting prize. So really, we want to, through this year, to make it front and center, because it's not just a frontier of scientific exploration, but is really a critical enabler for sustainable development. And I think this realization is very important. So by bringing the global attention to this field, we really hope that we can support the bridging of knowledge gaps, facilitating collaboration, scientific and technological collaboration, and really build, as you mentioned in the beginning, and I think Sandro also mentioned the importance of building capacity around the world in quantum science and quantum technology. So for us, and UNESCO being the Secretariat of the International Year, we really hope, with all the support of partners, including GESDA and the Open Quantum Institute, that this year will be really an important year to build those collaborative programs and networks that would allow even countries with less capacity in this important field of science and technology to be able to participate in the development of products and applications that could address better the development issues they are facing. So it's also an opportunity during the year to really bring inclusivity and equity to this field, this so important field of work. Otherwise, we will have the risk of again having a skewed development in nations that will be, of course, left out behind. We have a long-standing commitment, as you know, UNESCO has a strong commitment to foster inclusive and equitable science. And this international year for us, it's a powerful extension of this mission. And really it comes at the second year of the International Decade of Sciences for Sustainable Development. So for us also the fact that the International Quantum Science and Technology came right after the second, when the second year of the decade, the International Decade of Sciences for Sustainable Development starts, is also saying that we need, during this decade, to focus in certain scientific and technological fields that we know will play an important role for sustainable development, and therefore we need those international years to raise awareness, to build capacity, to build the networks for collaboration, and therefore making sure that indeed our ultimate goal that is highlighting also the groundbreaking advances in quantum, but the most inclusive one, it's how those achievements are indeed changing lives and how everyone everywhere in the world can indeed participate. So really, I thank you very much for allowing me to address you from afar. But it's been also very interesting to listen to the other speakers. And again, congratulations to GESDA for one more summit, and very sorry that I can't join you there. Thank you.
Well, thank you. Thanks very much, Lidia. And we look forward to the opening ceremony of the International Year of Quantum on the 4th of February at the UNESCO headquarters in Paris. It will be a very important moment. But we heard quite a bit from you also about how education is an important pillar also for inclusion, to make sure that we don't skew the development, as you said. So talking about education, maybe Anna, I can turn to you and ask you, how do you see the role of educational institutions like yours in equipping students, in equipping new generations with the skills that are needed to thrive in a new world of quantum technology?
Thank you. So if we were to choose a word to define what the university is, we would probably choose the word future. We train the future talent, we spark innovation, future innovations, and we share all this knowledge and innovations for a common future. So that tells us how to do this. The basis for this is to attract the intellectual leaders on fields that are at the forefront. As a technical university, we look at we are really at the forefront to see what are these technical fields that will change our future. Quantum is certainly one. And so to make sure we do this, we attract these intellectual leaders, and then themselves they associate in different ways. In our case, they have created the Quantum Center, and this Quantum Center then creates everything that has to be in these three areas. So they have created a new master in quantum science and technology that brings people together from computer science, from basic sciences, in particular physics, but also engineering. And this is a very interdisciplinary master that really is set for impact because of this interdisciplinary nature. Not only forgetting about the master students, we train the PhD students, but we shouldn't forget that we also train apprenticeships. If quantum technology is here to stay, we will need people that at the very basic technical level have the skills that we need for that. And so training apprenticeships is important. And not to forget that people that are at the working place, they also want to be trained on quantum, so continuing education will be key, and we have the basis to provide this to the population. Now, the Quantum Center then also thinks about how we can have a better future, and so they spark innovation, and so they have set funds to make sure that people that have great ideas, they can start their own companies, and so the first startups are now coming out of the Quantum Center. And another story is that willing to share our knowledge, EPFL has created other centers that are there for creating a better world. I can give the example of Essential Tech and Excellence in Africa, which have been created to really bridge the gap with the Global South, understand what the Global South needs, and also providing our knowledge for them. And in this sense, when Open Quantum Institute was incubated, there was absolutely, everybody saw their own path, their own contribution, and so several professors decided to contribute with different of the topics that you have presented before. So we had the stage ready for OQI, and people are very enthusiastic, and they're very motivated to continue on these projects.
Excellent, thank you. Thanks very much. Do you see the future, what could be some advice for other universities that maybe do not have yet a quantum curriculum? Maybe even in other regions of the world, what would be a path to achieve that?
There's a lot of, first you need the critical mass of people that are knowledgeable about this, that are leaders. If this is not the case, there's a lot of material online, and there's a lot of possibilities to collaborate with the universities that are leaders. We collaborate a lot with other universities and with the Global South, especially through the Open Quantum Institute. So I think I would just get in touch with people like us, but also other universities, to make sure that they go up to the level in a fast pace.
Excellent, thank you. And in fact, it's also with your support that the OQI team in the last few months has been able to put together an educational consortium to kind of boost the development of some educational tools, some of them online, some of them smaller scale, not at the academic level that you can offer, but with resources, mentorships, workshops. Today at the advisory committee, we launched the Hackathon in a Box, which is just a set of resources for those who want to organize events in their own countries on how to explore or get the first notions around quantum and quantum technologies and computing. And we have a number of countries that have already come forward and offered to host these hackathons. So many of them from, here's a map. I think the map is outdated, although it was updated yesterday, because more and more countries keep on coming forward and offering to host this. So it's quite encouraging to see that there is such a positive uptake, because in the end, as we said, not to create a new digital divide, we need to make sure that we provide access to this education to as many people as possible, and so especially in currently underserved regions. So it's important to continue spreading this, and I see the fact that map keeps on being populating as definitely a positive sign. So before I thank you all, we still have a few minutes. And so I'm wondering whether this will be a good moment to give the floor to questions from any of you who have questions for any of the panelists. And Lidia, thank you for still being online if there is any question for you. We have a very shy, okay, we have a hand there. If I can ask for a microphone to be. Microphone is making its way. Can you just please introduce yourself?
Yeah, hi, my name is Mourad Beji. I'm a Geneva-based journalist. It will be just a comment on your last slide. I don't know if you can show it. You said it was updated yesterday. Well, I mean, Turkey seems to be in Russia, Emirates in India. I would imagine you would be more precise in geography. And there is Lebanon, which is candidate. Well, it was made yesterday. I don't know, Lebanon, I hope it will be doing well, but so far, it's really difficult to imagine that Lebanon can host competition in quantum. So maybe, I don't know, you could review your slides, especially, right? If you say it was made yesterday.
Yes, and I hope that science and education transcends the boundaries of.
Yeah, but I mean, education should be maybe precise, right? Because if you speak about education and what you show, I mean, it's miseducation rather. So sorry to make this comment, but
Yes. Yes. Just wait for the microphone. Sorry, just 1 second.
Hi, I just wanted, I'm involved with the Hackathon in a Box. My name is Sana Ode. I'm a professor at NYU, and I'm the founder of the NYU Abu Dhabi Hackathon. I just wanted to say that we were really delighted that Lebanon had submitted a month ago, and they were the first people that actually to submit. So we encourage people, despite the war effort. I hope that people will be mindful and compassionate. And despite everything that's happening, we will support whatever comes in any country, especially when they're going through crisis. So at least we can be compassionate.
Thank you.
And if I may add, I think the last year hackathon was won by a team that was very international, that involved people from Ukraine, Palestine, Israel, really the people you wouldn't expect to share a team, and they won together. I think there's a lot to learn from them.
Yes.
So, hi, Kelly Richdale from Sandbox AQ and the World Economic Forum. It sounds like this is a really good segue into my question. What we see is that we're subject to a lot of geopolitical conflict, and quantum is going to be more and more in the spotlight. We're talking about here quantum for all, But what we see is there are already export controls being implemented around quantum. It's becoming part of an information technology arms race along with chips and AI. How do we ensure quantum for all, and what are the areas of commonality between the nations where we can ensure that there is access to quantum platforms, notably also quantum computing, for the global south, and particularly also non-aligned nations who are not part of the sort of like-minded nations as they're now being called? Thanks.
Was that a question to someone, or, or
well,
just a warning that export control is actually something to be careful of?
Well, maybe to you, Enrica, from the OQI perspective, but then anybody else who wants to answer.
I mean, as one of the advisors on OQI, export control was something that we started discussing actually early on in the conversation. And a lot of the application that we're focused on are not sensitive areas for the government. So we're hoping that it won't invoke problems. And OQI and the resources available through OQI is coming from international sources. And we insist on openness where the companies are making the resources available to everyone. And the learning and collaboration is what's open to everyone. But you know, certain IP developed or past IP will still continue to be protected by the original owners of the IP. So we are treading some fine waters there around IP and export control issues. But I think the topics we're focused on will help us still advance the mission without triggering any issues.
Thank you.
Enrica, can I just add something to this question?
Yes, please, Lidia.
Because another work that UNESCO is doing is how to guarantee that the recommendation on open science is really penetrating all these initiatives. And part of the basis of the international year, when we talk about building awareness, but also building networks of cooperation, will be based, of course, in open science values and therefore promoting the openness that you need in order to use these technologies and the scientific knowledge produced to really address the common challenges that the world is facing. So I think that also will unite us, because these technologies can indeed bring solutions to key issues, as we saw one related to water management in cities and how to prevent waste of water. So I think the open science recommendation of UNESCO is also a very strong point, and the Open Quantum Institute is very much using the same values and principles of that recommendation. Thank you.
Definitely, not only the solution, but also hope in what we now witness is a very complex geopolitical situation. We have, sorry, a couple of questions. So we have, can we have the microphone still? Oh, you already have my microphone, sorry. Then we'll come this way.
Right, thanks a lot. Ivan Estemin from the Swiss startup stage. It's back to the export control, right? So OQI inspires to be a place at CERN, right, where the multilateralism is a key value. Now, we are reliant on the best technological solutions that are out there. IBM is providing that with strings attached, right, that the US export control regulations are in place. Already today, Huawei is possessing the best 5G technologies. Possibly they will, it's not impossible that they will also possess the best quantum technologies. How do you see that coming in tension with intentions of OQI to be really open to technologies coming from all sorts of countries? Thank you. Maybe to Anousheh.
Thank you. Is any of the members like to take this, or? I'm trying to stay neutral.
Yeah, I think again, the fact that a lot of suppliers, for example, IBM is there, but we have Pascal there as well. So the fact that the supplier of the infrastructure and resources are international allows us to sort of make sure that access is available globally, and perhaps not every resource is available to every country, but in general, there will be access to resources where some of these works and use cases can advance and be tested out and implemented. So I think we haven't seen any case where there was a request, and this request was for a valid use case, and we couldn't provide them, resources because there's export control. Yeah. So hopefully we won't hit that, barrier.
But again, being in a pilot, in the meantime, if I can ask for the microphone to be brought here, and then we'll go to the back of the room. I think a part of being a pilot is also a part of the exploration of what are some of the opportunities and threats also in the governance and in the export control of new novel technologies. Can we look at new models of sharing technologies, overcoming some of the export control that we are aware of? Again, it's a pilot, and therefore it will be a good learning. This is why having an OQI as a platform of multi-stakeholders, where private sectors, governance, diplomatic communities are together, looking at this while we're still in a well-defined set of deliverables, which doesn't have to be scaled up to production yet. Therefore, is a good learning for that.
Yeah. And absolutely, the policy side is important, because a lot of time policies are made out of fear.
Yeah.
And by this experiment and pilot, we're allowing for conversation and collaboration to happen early on. Hopefully, it informs for better policies in the future.
Exactly. Thank you. Thank you for that.
Thank you, and congratulations for this important event. Congratulations, Fabiola and Dr. Enrica. Well, my question is just about collaboration and inclusivity, since the Quantum Institute is trying to have a connection with the SDGs. And how do we reassure or foster the proper link between the private sector and public universities? Mm-hmm. Because it's one of the most important elements for the future. I mean, talking about the future, and again for having into consideration the important element of inclusion. Thank you.
So we had Ambassador of Mexico to the United Nations and international organizations in Geneva. Anna, maybe can I leave this to you?
It's not an easy question to answer. When you have technologies that can revolutionize the world, I think private sectors tend to invest a lot and to keep it secret. This is the first phase. Then they tend to realize that maybe it's better to share with universities, because that's where the talent is. So the more they share with universities, the more they can advance. I think we're reaching this phase with quantum now. It's my impression. And so that's our chance to really bring together both of us with the big corporations to advance quantum. On top of this, we have out-of-the-box ideas that come from universities that can even short-circuit the big companies. We see Pascal as one of them. And so it's a nice competition that will, at the end, will make the whole field advance. So that's how I see it. It's a game between the two.
Thank you. We had some questions on this side.
Yeah.
Sorry, we still have. Where is the microphone gone?
Here.
It's in the back.
It's in the back. Sorry.
Good afternoon. I'm Tanvir Kabir, Counselor Political from the Embassy of Bangladesh in Berlin. So I have two questions, like echoing the the point Her Excellency Ambassador from Mexico made. Quantum technology is not about the capacity that computing, but also infrastructure. So, as we see the rise of friend-shoring as well in technological domain, so how do you see the infrastructure availability in the global south? It's not only that people learn in online, like coding, is you need infrastructure. And if it is not accessible, then it doesn't work. So I can see the global development in the map. It is not that many countries. Only I would say there's some allies of the US predominantly visible. Thanks a lot.
Perhaps I can just maybe clarify. So there was a very important decision made in the early days of OQI that we're going to focus on advancing the applications and not focus on the hardware. Because as you said, the investment and infrastructure required for the hardware piece, it's enormous, and not every country or every entity can afford to do that. However, we have seen that even today with the compute infrastructure is something that's made available at a cost from certain dominant players in the world and certain governments in the world. So the approach has been to bring some of those players in the quantum area and make cloud-based compute resources available, so you don't need to replicate infrastructure. And actually, it's not advisable to replicate infrastructure because the resources needed to build that, it's not good for our planet and climate. So if we make those resources accessible to everyone, which is at the heart of OQI, then we give a chance to the people who are working on actual uses of that infrastructure to continue to develop those applications without having to rebuild everything every instance.
Thank you for that. Anna, were you?
Just very shortly, if it was clear what is the quantum computer that is error-free, that really helps us solve the hardest problems, I would agree with you. We don't know this yet, and that's why also in Western universities, we don't invest in hardware, we invest in access to platforms, so it's all online also in our side.
Thank you very much. I know there are other questions, and I'm very excited to see such an engagement, but unfortunately, we need to come to a close. We need to honor the next time for the next session. But while I thank all my panelists and all of you for your great questions, I'd like to give a floor to Fabiola Gianotti, the Director General of CERN, that, as I said, hosts the OQI now. So Fabiola, your last words of wisdom.
Thank you.